Idempotency refers to the property of a function that produces the same result regardless of how many times it is executed with the same input parameters. Idempotency is particularly important in distributed systems where messages can be retried due to failures, timeouts, or other issues. It ensures that the system remains consistent without unintended side effects even if the same request is repeated multiple times. The Powertools Idempotency utility makes it easy to convert your AWS Lambda functions into idempotent operations that are safe to retry. In this video, let's learn how to get started using the Powertools Idempotency package, some of the key features, and how you can add it easily to your existing AWS Lambda functions. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos on .NET, Cloud, and DevOps. This video is sponsored by AWS and is part of my .NET on AWS series. The Idempotency utility provides a simple solution to convert Lambda functions into idempotent operations which are safe to retry. Some of the key features are that it prevents the Lambda handler function from executing more than once on the same event payload during a time window. It also ensures the Lambda handler returns the same result when it's called with the same payload. You can also customize the Idempotency key using James path expression. It also allows to configure the idempotency time windows and also other configurations that makes it easy to integrate with your existing Lambda functions and also customize it for your business needs. Some of the key terminologies to keep in mind when we talk about idempotency is that it means that the operation does not cause additional side effects if it is called more than once with the same input parameters. The idempotent operations will return the same result when they are called multiple times with the same parameters. The idempotency key is the key against which the whole request is considered to be idempotent against. Now it could be the whole request or it could also be a subset of that request properties. Let's see how we can add the Lambda Powertools Idempotency package into our Lambda functions. So let's switch over to Visual Studio. Here I have a new Lambda function, Lambda Powertools Idempotency, as part of my Lambda Powertools solution. This solution has multiple other projects that are used in my logging, metrics, and tracing videos from the Powertools library. You can watch those videos if you're interested, and the links will be in the descriptions below. Now in this function.cs, we have the DynamoDB context injected into the constructor, and it uses the context to add weather forecast data to our DynamoDB tables. Now in this, I'm using the Lambda annotations framework, because of which I have these attributes Lambda function and also the HTTP API. Now if you're completely new to annotations framework, I highly recommend checking out my video linked here and in the descriptions below. It makes it easy to build Lambda functions, especially when it comes to API endpoints like this. Now you can see that the weather forecast object is defined right below here, and we also have a serverless.template file which has the CloudFormation template to deploy this Lambda function. Now this template file is automatically generated for the Lambda function. As you can see here, it has the name data generated. Now I have manually added in a weather API Lambda execution role so that this Lambda function has the required permissions to talk to the DynamoDB and also write to CloudWatch logs. So you can see here it gives the access to weather forecast table and it gives the action dynamodb.star, which means all actions. Now this particular role is applied on the function using the role attribute on the Lambda function and passing in the role name with the add parameter. This is all from the Lambda annotations framework. Now in this Lambda function, you can see that there is a time-consuming process that kicks off right after we get the weather forecast data. Now this might be any time-consuming process in your business domain based on your application and the problem you're trying to solve. Now even if you don't have a time-consuming process, you might want to execute this request only once if it's the same weather forecast input for a given period of time. So let's say for 1 hour, if we get the exact same request, we want to add it to the database only once. Now in this particular case, it's going to add multiple times even if it's exact same data. So let's see how we can make this endpoint as idempotent. So let's first add the Powertools Idempotency NuGet package to start using it. So let's go to the Solution Explorer. Let's right click on the project, manage NuGet packages, and let's search for Powertools Idempotency. Let's add the AWS Lambda Powertools.idempotency NuGet package to this project. Now once installed, all we need to do is come back to our function.cs and add a new attribute. So let's add the new attribute idempotent, which is coming from the AWS Lambda Powertools Idempotency NuGet package. So let's include this namespace. With this attribute added, we have our Lambda function as idempotent. Now all we need to do is configure this idempotent package so that it can manage its state. Now this package currently supports using DynamoDB as its state management storage. Now it uses this external storage to track the request and responses coming to this function endpoint. Now to configure this, all we need to do is call the idempotency.configure method, which takes in an idempotency builder parameter, and we can configure this. So let's call builder.use DynamoDB and pass in the table name to use for this particular storage. So let's in this case specify Idempotency Table as the table name that this is going to use. So all the requests and responses that's going to come is going to be returned into this DynamoDB table to track idempotency. As you would have expected, this does add additional calls to DynamoDB every time your function handler is going to get executed. However, this gives us the feature of idempotency for your Lambda functions. And this is something that's unavoidable even if you're going to roll out your own functionality to track idempotency. Since we have defined a new table, idempotency table, let's make sure to add that in our serverless.template file so that it gets deployed along with this Lambda function. So let's switch over to the template file. Let's collapse this. I have the template resource already created, so let me copy and paste that, and I will walk you through that. Now here I have specified the idempotency table resource, specifying the name as we have configured in our Lambda function, and it also adds the attribute ID, which is of string type. This is the idempotency key that is going to be used by this package, and it sets up the other required properties required for setting up a DynamoDB table. Now once we have created this idempotency table, we need to make sure that this Lambda function also has rights to talk to this idempotency table. So let's modify our IAM role to add in this new DynamoDB table. So instead of specifying a single resource, let's make this as an array, and let's also pass the new idempotency table. Now in this case, you can pass in the explicit ARN like this, or since this resource is created in this same template, we can also use the function get function from CloudFormation and specify the idempotency table and get the ARN property from it. So here we have created the new idempotency table, and we have also given the permissions for this Lambda function to talk to that particular table. Now once this is set up, let's deploy this and see this in action. So let's right click on the project and say publish to AWS Lambda. This prompts up this dialog. So let's specify a stack name, which is Lambda Idempotency, and let's publish this function. Now this uses this CloudFormation template, uploads it to S3 and deploys it to AWS from there. The deployment is complete, so let's copy this URL, which is the URL to the API gateway that was just installed as part of the serverless.template file. So let's switch over to AWS console, let's navigate to stacks, and let's go to the Lambda idempotency stack. So here you can see the resources. We have the idempotency table, which is the DynamoDB table, the function, the Lambda permission, and also the API gateway related details. So let's open the idempotency table and also the Lambda function in a new tab. So let's navigate to the idempotency table, which has the partition key of ID string. To test this API endpoint, let me open Postman, which allows us to send post request to an endpoint. So let's make this request as post. Let's paste in the URL that we copied, and let's also specify the body and the appropriate route for this API endpoint. So if I switch back to function, you can see the route is /weather forecast. So let me copy and paste that in here. And let me also paste the body, which is going to be a raw in JSON format. So let's paste in the JSON body request. So let me paste it here. So here we have the city name Brisbane. We have the date 2023 5/12, the temperature, the summary text, and also the last updated date time. So let's make this request to this particular endpoint. So let's click send, and it sends this payload to this API endpoint. Now you can see this is performing the request, and it has come back with a 200 OK response. So let's switch over to our DynamoDB table to make sure that this item is getting added to our DynamoDB table. So let's go to the weather forecast table. Let's query this by Brisbane, and let's run this query. Now in here you can see there is a record for 2023 05/12, and it has the text as first and the temperature C as 10. Now if we open the Lambda function, so let's go to the monitor and view CloudWatch logs. Here you can see the logging for this Lambda function. Let's go to the first log stream record, and here you can see that it's written running the time consuming process. Now if I was to make an exact same request again with the same payload without changing anything else, this request must be idempotent. So let's click send again, and this time the response came back much quickly. It did not wait through the task.delay, which is a 5 seconds inside our function handler. Now if I switch back to the Lambda console logs and refresh this, you can see here that the new request has started and ended, but we haven't logged the running time consuming process, which means this Lambda function was not executed the second time. Now if I make another request exactly the same again and come back to our Lambda logs and refresh this, you can see again that it just records the start and end of this new request. Now if I come over to the DynamoDB table, and let's look at the idempotency table that was created here. And let's run a scan on this table. Now here you can see that there is one record with the status completed. And it also has an expiration time to live on this record. So if I open this item, you can see the key is idempotency Lambda function name and also a hash ID. Now this data is the response data. Now since our function does not have any response, it is an empty JSON payload. This also has an expiration Unix epoch time. So let's copy this. Let's look at this Unix epoch in seconds and let's paste in this epoch time and convert it to human date. Here you can see in my time zone, this is on December 5 at 5:46:40 a.m. and the time right now is 4:49. I made this request around a couple of minutes before. So this has a default expiry of 1 hour. So any request with the exact same payload is marked as idempotent and it is getting responded automatically. Now if I make any changes in this payload, so let's say for example I add it for a new date. So let's add a temperature for 4th of 12th. Let's also change this temperature to be 30 degrees and let's send again. Now this is going to make a new request, and since the payload has changed, this is not going to be idempotent the very first time. You can also see that it took a while for us to get the response. So now if I switch over to the idempotency table here and refresh this, we will be seeing 2 records. Now if I make the same request again, this is going to come back fast and we are not going to get any more records inside our table. Now if we change back the request to the previous one, so let's say for 5:12 and make it again, this is still going to be idempotent, and if we switch back, we'll see that there's no more records getting added in this case. So based on the complete request payload, these requests are currently idempotent. Let's come back to our Lambda function, and in here, this method currently has only one method parameter. Now if you have more than one parameters, then you need to explicitly mark the item that needs to be treated as the idempotency key. So let's say for example, I'm taking in the API gateway HTTP proxy request as an input to this function for some additional configuration checks on the headers, but I'm having the from body weather forecast as before. Now in this case, since there are more than one parameters to this Lambda function, we need to explicitly mark the item that needs to be used as the idempotency key. So for this, we can use the idempotency key attribute against this parameter. So let's specify the idempotency key along with the from body attribute. Now in this case, we are explicitly saying that it is the weather forecast data that needs to be treated as the idempotency key. Now by default, we saw earlier that the whole request was being treated as the idempotency key. So if you look at the record inside this table, you can see there is a unique ID getting generated for this request. This is using a hash function which is specified in the configuration object. Now right now it is treating the entire contents of this request that we are sending and creating the hash key from that. So even if I was to change the summary, so let's say first summary and make a send, this is going to recreate the hash and the idempotency key is going to be different. So now you can see that the request took a while longer, and if I come back to the DynamoDB table and refresh this, there will be 3 records. Now in some cases, we might need to control the idempotency key. So let's say in our scenario, we just need the city name and the date to be the idempotency key for this entire record. Now you can do this by changing the configuration of this idempotency package. So let's come over to the function. Under the configuration, let's modify this configuration. So before we call the use DynamoDB, We can also specify the configuration key. So let's say with options, this takes in options builder again, and let's specify options dot with event key James path, and let's pass the properties to use. Now in this case, we can specify city name and also the date. Now I'm passing this as a James path expression, about which you can read more at the jamespath.org. So this is using this query language for JSON to specify the key from the request object. So once we have specified this, let's make sure to build this and deploy this to our Lambda function and see this in action. The deployment is complete, so let's switch over to the Postman and let's make a new request. So let's specify this city name as Sydney and let's click send. Now in this case, the first request is going to create a new record in the Idempotency table and also save this data to our weather forecast table. Now the response has come back. So if I switch over to the Idempotency table and let's refresh this, and here we have 4 records as expected. Now if I was to change just the summary, so let's say I'm going to change the summary alone and click send, in this case, this request is going to come back immediately. Note that this data is also not going to get updated inside our DynamoDB table. Now in this case, we explicitly specified the key to be on the city name and the date alone. So only if these two changes will this record be updated. So we expect that the entire payload to be exactly the same. So if I switch back to the DynamoDB table and go to the weather forecast, and let's search for Sydney. So let's open this record for Sydney. And here you can see this text is still first summary, even though I removed the word summary from this request. So right now, this request is idempotent on these 2 keys. Now, if I was to change this date, so let's say 06, and make a new request, this is going to create a new record both in the idempotency table and also in the database. And if you run this again, you can see the 612 record. And you can see that the summary is just first. Now, if I was to look into the idempotency table, we will have an additional record in there as well. So here we have one more record added to this list. Now that we are able to specify the idempotency key, let's say we also want to ensure that some of these properties are exactly the same in the subsequent request. So let's say for temperature C, it should be same from the previous request. Now one way would be to include that as part of your idempotency key, or we can also add request validation on idempotency package. Now when you add request validation, it will enforce that those properties are exactly the same as we saw in the previous request. So to add request validation, so let's switch over to the function.cs. Again, let's update the configuration. So when we specify the with key James path, let's also specify configuration. So let's say with payload validation James path, and let's pass in the path to use for validation. Now in this case, we need to use the temperature C property so that this should be exactly the same as we saw in the previous request. So let's build this and deploy this and see this in action. The deployment is complete. So let's switch back to the Postman. Let's make a new request to the city London and let's click send. Now in this case, the temperature C is 10. So the request is getting executed. So let's switch over to DynamoDB and let's refresh this. Now you can see that there is a new property added, validation, and only one record has the value populated. Now this property is the hash of all the validation properties and the values of those properties. So if you make a subsequent request with the exact same payload, this is going to come back as 200 OK. However, if I change the temperature C payload from 10 to 11 and make this request, this is going to return a 500 internal server error. This is because this has thrown a validation error. So if you switch back to the AWS console, so let's go to the function logs, Lambda stream, let's go to the latest log stream, and here you can see that there is an exception thrown. So you can see the payload does not match stored record for this event key. Now this is very important to make sure that you capture these requests in which the payload changes but the idempotency key does not. Ideally, this should not happen. However, this allows to catch such scenarios and handle for it inside your application. Now, if I make a request with the same 10 temperature and make another request, it is going to come back as 200 OK. Now, if I go create a new request for a different date, it is going to add that to the DynamoDB table, and then it's going to be idempotent on those 2 keys. I hope this helps you to get started using the Powertools Lambda Idempotency package. The Idempotency package makes it extremely easy to convert your Lambda functions to be idempotent. We saw how to specify idempotency, how to customize the keys to be used for idempotency, and also to add payload validation. If you like this video, please make sure to hit the like button. If you want to be notified of future such videos, please hit that subscribe button. It also helps me to grow this YouTube channel. Thank you and see you soon in the next video.